This chapter is all about consistency, and you guys, we're going to learn another measure of spread called standard deviation. So when we're talking about data being consistent, data can have like a similar average, but it can have different consistency. For example, we've taken 4 tests in this class, okay? Let's say the first student's test scores were maybe in terms of percentages, a 65, a 74, an 82, and an 89, okay? The second student's averages are maybe a 75, a 72, a 79, and an 80. One student they have similar averages, but one student is more consistent than another, okay? So what does it mean to be consistent? When consistent, I kind of breaking it down to 2 ways to explain it here. When an athlete or team's performances are very close to each other. So their performances or their data is close together. You can also think of it as when performances do not vary much from the average performance. Okay, so those are 2 ways to kind of think of data that's consistent. Okay, I have 2 sets of data below, data for team 1 and data for team 2. Go ahead, calculate the mean for each data set. So the mean, remember X bar is mean for team 1 and the mean for team 2. What'd you get? What's the mean for team 1? Anyone? You guys, even just look up here. What's the average of these 5 numbers? 5. Good. What about the mean for team 2? You can add them all up and divide by 5, or I know some of you are probably putting it into a list and then 1 variable stats. Either one works. 5. Okay, so they each have the same mean. Well, which team is more consistent? Team 1 or team 2? Team 1. Team 1. Why? Yeah, because their data is closer together. Okay. So we're going to use measures of spread to help us measure variability or consistency. 2 measures of spread we learned in chapter 4. First one was the range. Who can remind me, what's the formula for range? Anyone? Max minus min. And in chapter 4, we also learned about the interquartile range, which can be abbreviated IQR. Which is, what's the formula for IQR? Good, Q3 minus Q1. Now we're going to add another measure of spread into the mix called standard deviation. Standard deviation, you guys, measures the spread of the distribution using the squared deviations from the mean. And I'll show you what I mean by squared deviations in the formula on the next page. So it measures the spread of the distribution using the squared deviations from the mean. Now recall the model we used at the beginning of this course, which is performance equals ability plus random chance. So if we're talking in terms of this model right here, you guys, you can think of standard deviation as the typical distance an athlete's performances are from their ability. So that's one way to interpret standard deviation. Another way, remember, performances are just the individual data points. Ability is best measured by their average, otherwise known as the mean. So we can also think of standard deviation as a typical distance a data point is from the mean. It's a typical distance a data point is from the mean. Remember, another word for mean, average. You could use that as well. That's another way to interpret. Okay, so let's take a look at data on the next page. It says, let's compare two players' performances with the same ability, but two different standard deviations. So the same ability, but two different standard deviations. Okay, the first dot plot, I'll just call this, I'll be really creative, call this player number 1 and player number 2. Let me see if I can zoom in just a little. Okay, guys, if you read it up top, it says that, let's zoom in just a little bit. Player number 1 had a mean of 20 and a standard deviation of 5. Player number 2 had a mean of 20 and a standard deviation of 2. And it makes sense that they both have a similar mean because they're both centered right around 20, correct? Okay, guys, using the dot plots above, which player seems to be more consistent? 1 or 2? 2, I agree. And there's kind of two different reasons you could give me. What's one reason you could give me why? Yeah, William.
The data isn't spread out.
Yeah, the data isn't spread out as much, or in other words, the data is closer together. Perfect. So that's if you're looking visually at the dot plot. Some besides William, what's another one?
Standard deviation smaller.
Perfect, lower standard deviation. Good. Questions on those? It'd be good to know both reasonings, okay? Because maybe on your test, I'll list out statistics and ask you who's more consistent. Maybe I'll give you a picture of a graph and ask you who's more consistent, okay? Okay, so calculating standard deviation by hand. I'm not going to make you calculate any standard deviations by hand, but I do want you to understand a little bit what goes on with the formula, because then you'll be more likely to understand what standard deviation means. So here's your formula right here. Standard deviation, you guys, is the symbol S. Okay? So what do these variables mean? X sub 1, X sub 2, X sub 3, X sub 4, all the way. All those different values would be your individual data points. X bar is what? We learned what X bar was in chapter 4. Yep, the average or the mean. You can write either one. Anyone know what N is? Yeah.
Any number?
Not, you're close, not any number. This little, I get what you're saying there. This little subscript meant any of the data points.
N means the total number of like data points, I guess. So
Yeah, your total number of data points, and otherwise known as sample size. Okay, perfect. So if we have 20 data points, our sample size is 20. And then this difference right here between the data point and the mean, we call that the deviation. Now in statistics, we like to square a lot of our numbers because notice when I subtract the data point minus the mean plus the data point minus the mean, if I don't square those numbers, the negative numbers and the positive numbers would just cancel each other out and I'd get 0. And the only way I can have a standard deviation of 0 is if every single data point is what? The same number. Okay, the only way you can have a standard deviation of 0 is every single data point is the same number. So we square those values, so it's not. Okay, here we go, guys. I'm going to show you how to do this in your calculator. First thing we do is put that data in a list. If you need to, write down the steps. But how do I put the data on a list? Where do I go? Stat. And then what? What do I do next, guys? Yeah, edit. Now, if I have data in a list and I want to clear it out, a little recap. I know it was after spring break from chapter 4. Whoops. You arrow to the top so the list number is highlighted. Hit clear and arrow down. Make sure you're hitting clear and not delete because delete will delete your whole list. So again, arrow to the top so the list number is highlighted. Hit clear. Clear is right below the down arrow. Arrow down. Okay. Go ahead and type in those 5 data points. Make sure you type in the data correctly. If you type in one data point wrong, you guys, that's going to throw off your mean and your standard deviation. Okay, from chapter 4, how do I get one variable statistics? I go stat, then what? Good, arrow over to calc. And that's number 1. Now, I'm trying to see here. Make sure this is, I put my data in list 1, so hit second in the list number to make sure it's on list 1. For those of you that did not get this screen, did anyone not get this screen to come up? I know there's another.
I know how to look at it. Oh yeah, I just get one variable.
Perfect, yep. So you're either going to get the screen I have right there or this screen. If you get the screen on the left, just hit enter, okay? If you get the screen on the right, you got to change your list number and enter all the way through. Now, I told you guys standard deviation was which variable? S. Now, some students in the past were like, wait a minute, my teacher in Algebra 2 told me standard deviation is sigma. They're actually both standard deviation, okay? Sigma is population standard deviation, S is sample standard deviation. In statistics, we always assume our data is from a sample, right? Because do you know how hard it is to get a population set of data? Okay, to get, if I wanted to find the population GPA of PCEP students, okay, I'd have to get a hold of every single student here and get their GPA. Okay, that's a lot to do, and that's hard to get a hold of. So we always assume we have a sample. So always go with S. Okay? You guys, they're always going to be very close to each other. The reason why S is always going to be a little bit larger than sigma is because the formula is slightly different in the denominator. One divides by n, the other one divided by n minus 1. Okay, so S. I'm going to round to the hundredths. The hundredths is how many decimal places? 2. So 2.24. You don't have to have the about symbol. Whenever I round, I try to use it. Questions? Okay, perfect. Yeah.
So we're doing it for SX?
Yeah, they just call the variable x. Okay, but yes, in your calculator it comes up as like s of x. Okay, good. Okay, I want you guys to try and find the mean and standard deviation for the data set for wind speeds. So right here, mean and standard deviation. So clear out your list. Remember, just to recap, you enter the day in list 1. We're using S for standard deviation. So find the mean, find the standard deviation. Okay, I'm gonna walk around real quick. If you check your answers, that's what I got. If you did not get that information, you could have typed something in wrong. Remember I told you, just typing in one data point wrong will throw off the mean and the standard deviation. Just let me know if you're not sure how to do this. Did you guys get 25 for your mean? And 7.70, just because we're running in hundredths. If you don't write the zero, it's fine.
How did we get 25?
That's my mean. If you typed in your data correctly, that should just be your mean. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they added them all up and divided by 10. That's what your calculator did.
Yeah.
So you just type it in. X bar is the very first number that comes up. It's at the very top of the list. Okay? Okay, here we go. It says interpret this value. We wrote these down at the beginning of the notes, but again, here's the interpretations for standard deviation right down below. If you want to highlight it, go for it. Remember, there's two types of ways you can interpret. So we're talking about wind speeds here. So typically, wind speeds are about 7.7. What's the unit here, guys? Yeah, miles per hour from the average wind speed. Or you could just write from the average or from the mean. Either one works. Now, for the next one, it says add 2 miles per hour to the data points in list 1 and put these new data points in list 2. Okay, so go back to your list. So we're going to add 2 to every data point. So 20 becomes what? 22. 24 becomes 26. Now, they want you to find the new mean and standard deviation of list 2. So they want you to find the new mean and standard deviation of list 2. So this time, go back to stat, calc, one variable stats, but I'm going to hit second number 2. So list 2 comes up. If you guys have a calculator that looks like this operating system on the left, you don't want to just hit enter. You got to tell the calculator list 2. If not, it's going to keep recalculating stats for list 1. So again, second and the list number. What's your new mean? 27. However, your standard deviation is still 7.70. Okay, you guys think about it. Let's say I thought the chapter 4 test scores were too low, so I added 2 points to everyone's score. When I graph your data is all going to shift up on the number line. So the measure of center is going to go up by 2, your mean. Did the data become closer together or more spread apart when I added 2 to everyone's score?
No.
No, so your standard deviation stays the same. Your data just shifted, so your measure of center changed, but not your measures of spread. So it says, what are the general rules for when you have a constant value added or subtracted to every data point? Okay. When a constant value is added or subtracted to every data point, the mean is either going to, well, it will increase by that constant, but if you subtract, it's going to do what? Decrease by that constant. So your measure of center will change, your mean will change. What happens to your measure of spread, your standard deviation? It's going to do what? Stay the same. Okay, I would definitely highlight star. Okay, hopefully you understand it. The goal is for you to understand why that works, and we'll hopefully get there. Okay, we're going to have more examples tomorrow.